Please put full screen.
Slideshow. This is full screen.
Sir, in slideshow mode, please click on view option. Sir, near that home, in that row, last one view. Yes, sir.
Okay.
Slideshow. Yes, sir.
Slideshow
From beginning, sir.
from beginning. Fine.
Yes, sir. But now it's not in slideshow mode. Can
Oh,
you click one? Can you please click one more from beginning?
oh. From beginning I clicked.
Yes, sir.
Not. So it is not in full screen.
No, sir.
View. Normal.
No.
Okay.
Please click on slideshow only.
Now I am just clicking fit to window. No. No, click. So here I am getting full slide,
Sir.
but not in the display now.
Sir, can you please click on slideshow again? Slideshow comment.
Now what I can see here is stop sharing, hide. Only those two are in active mode.
Sir, in that orange row, that file home, insert in that slideshow.
Slideshow
From current slide.
from current slide. Clicked. At least can you see the
Yes.
text?
Yes, sir.
Now common durability problems in concrete.
Yes, sir.
And now concrete construction specifications.
Yes, sir.
But then why it is not showing in full screen? On my system, it is showing full screen.
Oh, okay, sir. Then I will log in once again. Maybe it's my phone problem.
Mhm. I don't
Sahi ma'am,
know.
for everyone it is like that only, ma'am.
Pardon, sir?
Yeah, for everybody it is like this only, sir.
Uh-huh. So what do you mean? You want me to continue this way or you want me
No,
to
no,
log out?
actually, you can do another one more option is there. View,
Uh,
there is full slideshow. There is one option is there. Let that Sahi miss comes once again. I will tell, she will instruct you, sir. No issue, sir. So I am Vasudevar from the department. So we welcome you, sir, for this session.
thank you for
And most
inviting
welcome
me.
to this CSIR sponsored workshop, sir.
Yeah. So that is why I thought, okay, it is better to join this course. Okay. And I thank you, the organizers. Okay.
Yeah.
And hoping that the participants will get benefited from this lecture.
Yes, sir, because it's a overwhelming response we are getting on this regard, sir.
Okay. Nice. So
Yes, sir.
should I start or what is the scheduled program?
Which one, sir?
Now should I start my talk?
No, no, just wait, sir, because
Okay.
some of the participants also is set to enter. It's
Right,
just
right,
nine
right.
only is there.
Okay. As
Just
soon
wait
as
for
you
a while,
say,
sir.
then I will start. Okay.
Yes, sir. Yes, yes.
But
Yes.
please bear with me. I think these slides, I don't know whether you can able to see the full slide or I don't know.
I think there is some glimpses. We will sort it out, sir, immediately.
Fine,
Let she
fine,
enter. No issues, sir.
fine.
Be it calm, sir. No issues.
Okay.
Sir, still the PPT is like that only. Can you please stop sharing and again, once again, please share?
So you want me to close and share again?
Stop sharing and share again.
Stop sharing. I'm worrying.
It's okay, sir. No problem.
Wait. Anyway, I just stopped it. Now it is stopped, na?
Yes, sir.
It is
Okay.
stopped.
So now what should I do? Yeah. Now window share
Entire screen.
entire screen. Where that entire screen is appearing? I'm not able to see.
Sir, while sharing, share entire screen, one option is there.
So normally here I will click this slideshow. I am not able to see that entire screen.
Uh,
Entire screen where it will appear.
Sir, before this, there is three command: entire screen or. So then, can you zoom and zoom the PPT so that we can start, sir?
That is fine. Only thing the flow.
Uh,
Uh, what can I say? It will not go in
As
line with my talk.
as it zooms, it will not go to the next slide unless we come back to normal.
Mm-hmm. Start slideshow.
Sir, Bhaskar sir, when
Yes.
you click on share screen, what is the immediate window that is appearing?
So now is it full screen?
No, sir. Sir,
No.
please stop sharing once again.
Stop sharing.
Okay. Now, share your screen. When you click share screen, what is the first window that appears?
Present now. Share screen. Choose what to share with meet.google.com. Okay.
Okay. There
Please.
can you see an option entire screen?
Entire screen is there, but when I tried that entire screen, the slide itself is not appearing. No. Entire
Sir, can
screen
you
I have taken
please
now.
try
Okay.
again? Okay.
Now entire screen you see I am sharing.
Okay. Sir, now please take your PPT.
PPT.
Yes, sir. PowerPoint presentation and we'll put it in slideshow mode.
No, but here it is. I am not able to see my PPT. Okay. Just wait. Just
Yes, sir. Now it's fine.
Yes, now it's okay. Fine.
It's okay.
Yes, sir.
Yes,
Yes,
sir.
sir.
All right, fine.
Sir, we can start, sir.
Yes, please.
Sir,
Sir,
shall we?
most welcome, sir. We can start the presentation, sir.
Okay, right.
Good afternoon, all. Let us start the technical section on concrete durability, importance of durability performance specifications by Dr. Bhaskar S. Dr. Bhaskar has put his MTech from Structural Engineering in JNT University, Hyderabad, and also has doctorate from Indian Institute of Technology, Bangalore. He is currently working as a chief scientist in CSIR Structural Engineering Research Center, and he has also got an award of Achievement Award for Scientists in 13 CIDC Vishwakarma Awards 2022 from Construction Industry Development Council CIDC, and also got an award of Best Paper Award in the Symposia on Corrosion in Structures and Design in CSIR 2015 by NACE International Goodwill Section India. So over to you, sir.
Thank you. Thank you for the brief introduction. And once again, I thank you, the organizers, for inviting me to this FTP program, Faculty Development Program. Okay. So now I will start my talk. This is mainly on concrete durability, importance of durability performance specifications. We all know that concrete is a man-made material. It is not the factory made or machine made. So here the quality control is very, very important. And many times you people, whoever maybe, whether faculty or engineers, even students also, where they are residing, might have seen the symptoms of like rust stains, cracking, and other things, despite following the design guidelines and whatever subject knowledge we have. But why the deterioration issues are coming, though we follow specific codes, guidelines. Okay, so this background makes me to present and share the knowledge what I gained from the site investigations, in situ investigations during my career in CSIR SERC, that is Structural Engineering Research Center. So with this background, and I am just starting my presentation, and the presentation will be like this. The main objective of the presentation: common durability problems. So concrete construction specifications, in the sense, despite following the design guidelines and the theory of reinforced concrete design, why we are facing the long-term durability issues. So there we should also know the what are the deterioration mechanisms. So before going to that, what is that the transport mechanisms in concrete? I will touch upon that one. And the main durability issue uh, that we can protect the concrete structure from the surrounding environments is make the concrete impermeable. So therefore, the penetrability or permeability of concrete plays a major role for the durability of the concrete structure. So there are some tests to evaluate the durability parameters of concrete. So one should know, because many people know the strength evaluation at 7 days, 3 days, 28 days, but most of the times, many a times, strength will not be directly related to the durability parameter or durability performance of concrete. Okay, and it is more important that the reinforced concrete structure or the reinforcement that is embedded inside the concrete most of the times is getting corroded, and thereby the lot of corrosion or deterioration issues are coming. So what are the different corrosion mechanisms? Why corrosion of rebar occurs? So I will touch upon that one. And durability performance specifications. As I mentioned in the initial remarks, that despite following some specifications, guidelines, so we are not able to control the deterioration of concrete structure when it is exposed to aggressive environment or the surrounding environment. So we may have to add up some specifications which will take care of the durability issues, like quality control of the cover concrete and the required amount of cover thickness. So for that, I will show one case study, and finally I will summarize my presentation. So as I said, the main objective is emphasis on the concrete durability for a longer service life. Okay, so we talk many times durability, durable material. In day-to-day life also we use this word durability. Okay, so what exactly the meaning of durability? So it is the ability. So now we are talking about the concrete. So it is the ability of concrete to last for a longer time, without significant deterioration. So it is very common that deterioration will happen when it is subjected to the surrounding environment, when it is interacted with surrounding environment, but that deterioration will be within certain limits till its design life. Okay, that means without a significant deterioration, the structure survive for its design life or intended life. That is what is the durability. So here it is primarily concerned with the interaction of materials with the service environment. The durability of any material is primarily concerned with the interaction of the concrete. So in particular to this lecture, so with the surrounding environment. So whether it is carbonated environment or chloride environment or industrial environment or say it is a water retaining structure, then it is subjected to complete water exposure. So that is the environment we should look in. And then finally, my talk will be specific to the rebar corrosion, because if you see the literature, if you see this pie chart, most of the times or most of the literature reported that so especially in the case of reinforced concrete structures, nearly 65 to 70% of the structures are deteriorating mainly from the corrosion point of view, corrosion of rebars, whether it may be a chloride induced or carbonation induced. So most of the deterioration is due to because of the corrosion of reinforcement. Though it is embedded inside the concrete, but how the rebar is corroding. So that is what the main talk of this presentation. Okay. In addition to that, okay, these are some of the common durability problems or issues. One and foremost is corrosion of steel in reinforced concrete and sulfate attack if the surrounding environment or the groundwater contains sulfates, then the concrete will get deteriorated because of that sulfate attack. And alkali aggregate reaction, feedstock cycles are damaged. So these are some of the common durability issues when we are talking about the concrete. But for all these durability problems, something sorry, the deteriorating agent has to enter inside the concrete and has to react with the products of concrete, that is the hydration products of concrete. So that means the deteriorating agent has to enter inside the concrete. That means how it will enter through the cover concrete, whether it is a chloride or carbon dioxide or sulfate. Okay, so that means penetration of the deteriorating agents that are available in the outside environment. And in addition to that, the deterioration mechanism needs the presence of moisture or water. Okay, so that means most of the times the presence of moisture is essential to take place, whatever be the deterioration, whether it is chloride induced corrosion or carbon dioxide induced corrosion or sulfate action. So there, the word again, the durability or the penetrability of concrete plays an important role. So that is why I used the word penetrability or penetration or permeability. All these lead to the durability of concrete. So again, the durability or the penetration related to the transport properties of concrete, and in particular the transport properties of cover concrete, because that is the one which uh, acts as a barrier to uh, to avoid the entry of these deteriorating agents. But as of now, what we are doing, we are following the design guidelines, like for example IS 456 or design of concrete structures by limit state method. Okay, and some specifications. So the specifications, we say that is the prescriptive specifications. Like, for example, what cement ratio you are fixing to keep the concrete of good quality and to get the grade of concrete or strength of concrete what you want. And for durability issues or for taking care of the durability issues like shrinkage and the temperature affects minimum cement content and maximum water cement ratio, grade of concrete. Okay, we are defining and we are designing the concrete as per these prescriptive specifications. And at the end, what we are following is the acceptance criteria as tube strength at 28 days, and that too on the standard tubes that we are casting in the laboratory and curing for 28 days. And prior to that, during casting, we are taking utmost care for compaction, consolidation, and curing. And that we are taking as the acceptance criteria. But is it truly representing the concrete that is available on actual structure, that is as built concrete structure? So that is where the gap is coming and all the durability issues are coming up. So that means one of the main reasons for deterioration is inadequate acceptance criteria. So that means tube strength alone will not be sufficient. So in addition to that, we may have to bring in some other parameters that are to be followed and that are to be ensured either during the mixed design or after construction of the structure. Why? Because those parameters have to ensure the impermeability of concrete or the penetration resistance of the concrete. So there, this transport mechanism of concrete will come into picture. So that means in addition to the cube strength, we may have to bring one or two parameters which evaluate the transport properties of concrete. And if we keep those transport parameters to a limit, that means the concrete should not exceed this limit, then it can perform well. So something like that. Okay. So before that, what are the transport mechanisms that we should know? So as I said, most of the deteriorated mechanisms like carbonation, rebar corrosion, leaching, etc. are related to the ease with which the fluid or ion can move through the concrete. And the primary mechanisms involved in fluid or ion movement are: one is capillary action, that is sorption. So as we know, many of the plants will take water from the ground because of the capillary action. So that is sorption. And next to fluid flow under pressure, that we say permeation. The third one is flow under a concentration gradient. We say that is diffusion. So that means chemically we say if the chloride concentration is more, for example, okay, so the chlorides try to move from one area, higher concentrated area to lower concentrated area through diffusion. Okay, and the fourth one is movement due to an applied electric field. So this is migration. So the migration is most of the time the ionic flow or mm, what can I say, the electron flow. So most of the times this mechanism will be seen in the laboratory experiments where we go for accelerated tests. So as I said, sorption refers to uptake of liquids into a solid by capillary suction. So that is, it is measured by using parameters such as bulk absorption, sorptivity. There are some standard procedures are available. Maybe I don't know whether you people started working on this, means in the laboratory. So permeation refers, this I already told, permeation fluids under an external applied pressure, and this is diffusion movement of gases or ions under a concentration gradient from an area of high concentration to low concentration. So migration, as I already told. So again, essentially what we are looking is to ensure impermeable concrete, impermeable cover concrete in particular, I can say. Okay. So permeability is we are going to measure. So there are different durability tests. I'm just giving the list of the tests for water penetrability, sorptivity test, water permeability test as per DIN 1048 or Garmon's standards. Okay, for chloride permeability, and nowadays people are using this rapid chloride permeability test. as per ASTM C1202. Accelerated chloride migration test, in that two varieties are there, steady state and non-steady state. Norwegian standards are available, NT build 355, NT build 492, okay, and bulk diffusion test. So here the specimen is exposed to a pool of water for longer durations, and the other one is salt ponding test. So exclusively for evaluating the chloride permeability of concrete. And similarly for gas permeability, where if you want to know the gas resistance of concrete, mm, air resistance or oxygen, because when corrosion to initiate, the presence of oxygen also important. So if there is no oxygen, the corrosion reaction or corrosion process will not, corrosion progress will not take place. Okay, so to know the oxygen permeability of concrete or the carbonation diffusion coefficient, so these two tests are being used. Okay, so this is sorptivity test, just a laboratory test procedure I am giving. This is the line sketch where the specimens are placed on a weld mesh, and the this is a uh, cylindrical specimen, 100 by 200 cylinders were cast and sliced into 50 thick, okay, 50 thick slices were kept. Uh, okay, this is the procedure, because to take out all the moisture that is available in the concrete, and then we put in the oven for 24 hours, to 48 hours, and then cool it, and when it becomes the dry specimen, so that will be placed over the water surface. Okay, some 4 to 5 depth only will be exposed to water. So from one side, water will try to enter inside the concrete because of the sorption. So then increase in weights at regular intervals will be taken, and finally the sorptivity coefficient. So rate of uh, absorption of water, I can say. So rate of absorption of water is nothing but the sorptivity. And this is another test method, DIN water permeability test. So uh, it provides the penetration depth of the pressurized water into a concrete sample. So here you can see the samples, the cylindrical samples are fixed in this setup, and a fixed amount of water pressure will be applied. You can see here the water pressure, and this pressure, the specimen will be subjected to 7 to 2 hours under that water pressure. And once the test duration is over, the specimen will be taken out and split into two halves, and then we'll measure the penetration depth. So that will give the penetration depth of water penetration depth, indirectly will give the permeability of concrete. So you can relatively evaluate the penetration depth of concrete. So if the penetration depth is less, then we say that the concrete is less permeable. This is another test, Garman water permeability test. This can be, the advantage of this is this can be used on site also, whereas the previous two tests normally we perform in the laboratory. So this is the setup, and this can be fixed either on horizontal surface or vertical surface, and a constant pressure will be maintained on the surface, and the pressure loss, because of the permeation of water, there will be a loss in pressure that will be adjusted using the micrometer screw, and based on that the flux or the water permeability rate will be calculated. And this is the classification given or reported in the literature. So if the permeability range is 1 to 10 power minus 3 and above, then it is said that the concrete is highly permeable. So all these tests are being used to evaluate the relative performance in terms of the durability, in terms of ensuring the durability of concrete. So in actual practice, we may have to use some of these durability tests while designing the concrete mix. Okay, as we do for evaluating the grades of different concretes. So here also the durability parameters, some classification we may have to give depending on our requirement. Okay, and then we try to evaluate these durability parameters. And this is chloride. For evaluating chloride penetrability, there are different tests available. So this is a 90-day salt bonding test. So here in this photograph you can see the cylinder on one surface, say either top surface. So artificially we created a pond type. Okay, and then the NaCl solution or the water 3% NaCl with water with 3% concentration of NaCl is poured, and 15 mm depth is maintained for a duration of say for example 90 days or 60 days or whatever it is. But if the concrete is a very low water cement ratio, then you have to expose it for more number of days. Okay, so here this is more similar to the natural exposing conditions, thereby it takes more time for the chlorides to penetrate inside the concrete. So here it is exclusively the mechanism is diffusion, and generally people will do for 90 days testing, and that is why some people, some researchers thought that okay, 90 days is too uh, too much time to wait. So that is why people brought out some accelerated corrosion tests. But this is more realistic, means more close to the realistic environment. So high performance, low water cement ratio concrete still take more time to even small amount of chlorides to enter inside the concrete, say 5 mm or 6 mm. Okay, and once the exposure period is over, we take this sample and surface cleaned, and then you have to slice this top surface at different thicknesses, say 1 mm or 2 mm, 3 mm, depending on the requirement to draw the chloride profile or to evaluate the diffusion coefficient. So, as I said, that takes more time for the permeation of chlorides inside the concrete. So, that is why accelerated test, that is rapid chloride permeability test, has come out, and this is a 6 hours duration test, and this is the uh, specimen setup. So here this is the concrete specimen placed between two reservoirs, I can say. One is zero point 0.3 normality of sodium hydroxide solution one side, on the other side 3% sodium chloride solution. So here essentially what we are doing is we are impressing the current so that the chloride ions try to move from this reservoir to the other hydroxide reservoir. So that means the chloride ions which are negative ions, they try to move towards the positive side. So thereby we try to find the amount of current that is passing. Okay, so that is measured in terms of coulombs, ampere second. So this is the RCPT test setup. So total amount of charge passed is used to predict the chloride ion permeability. The title says it is chloride ion permeability, but in concrete, because of the it is accelerated test and we are impressing 60-volt current, sometimes the solution may get heated and the specimen also may get heated. So in addition to chloride ions, the ions that are available in the concrete pore solution also try to move and try to what can I say, affect the total amount of charge passed. So thereby, strictly speaking, it is not only the chloride permeability test; it is just the amount of charge passed. Okay, because of many other ions also that could be available in the pore solution, they also will contribute a little bit. Otherwise, for relative evaluations, we can very well use this RCPT test. But when the concrete is admixed with, say, for example, chemical admixtures or mineral admixtures, it is better to go for other tests which Norwegian standards has given is that is rapid migration test. And here this is the classification given by the ASTM C1202. If the chloride, the charge passed, if the total amount of charge passed is greater than 4000, then it is said that the chloride permeability is high. And if it is in between 100 to 1000, it is low. And this is what I am telling. Compared to the rapid chloride permeability test, rapid chloride migration test is more reliable, because here we take we adjust the voltage with respect to the concrete property. So here the voltage is not fixed and time duration also not fixed. Of course, this is also accelerated test, but 60 volts we are not applying here, whereas in RCPT we are applying 60 volt current. So sometimes the specimen may get heated, and other ions also may try to move, so thereby the total charge pass will get affected. So here that is not there. And also, if any chemical admixture also present in the concrete, and this will give a reliable test this will give when compared to the previous RCPT test. So that is why most of the researchers nowadays using the Sentibility 492 test. So here also the procedure is same, similar. This is the test specimen, 100 diameter by 50 thick specimen is placed inside this inclined test setup. This is also intentionally created so that if there is, if the specimen is getting heated up, and because of this inclination, the air bubbles or whatever the reaction that is taking place will be nullified. And so here it is being accounted the concrete resistance. So therefore the applied voltage and test duration will be adjusted accordingly. And therefore the test results are less affected by the presence of admixtures. So, and also here what we are doing, no? We are not simply measuring the charge passed. Here we are taking out, once the test duration is over, we will take out this specimen, we break the specimen and we measure the chloride penetration depth alone. So this is more realistic when compared to the RCPT. And the other one is diffusion coefficient test. This is also similar to the RCPT test setup, but here we apply a very low volt current, that is 12 volts. Therefore, this testing will take, depending on the uh, concrete quality. Sometimes it may take 2 days, 3 days. Sometimes it may take even 1 week to get a, reasonably okay number of test points, so that we can draw the diffusion uh, coefficient, diffusion line, diffusion of concrete, and based on that we will find the diffusion coefficient of concrete. And many researchers are using this diffusion coefficient as an important parameter in evaluating the service life. Service life, that is from the durability point of view, from the corrosion deterioration point of view. And this is oxygen permeability test, and it is uh, given by the South African standards. So here also oxygen permeability coefficient will be evaluated. So this is a falling head permeation permeameter test. Concrete sample is pressurized with oxygen to 100 kilopascal, and the pressure drop is monitored with time. So this is the test setup. So here concrete specimen is placed. This is the um, uh, pressure vessel containing oxygen, and oxygen cylinder will be there by the side of this one. Okay, and oxygen will be sent through this concrete sample, and we try to keep the pressure 100 kilo pascals because of the permeability and other things. So the pressure will get reduced. So that will be taken into consideration, and then the oxygen permeability coefficient will be evaluated. So as I have explained some of the durability tests, So this is the summary of different durability tests, okay, and the durability parameter that is being evaluated, and the major transport mechanism that is taking place, and the literature, corresponding literature. So, for example, rapid chloride permeability test, here total charge passed is being evaluated, and the main transport mechanism is migration. Because, as I said, most of the accelerated tests, the dominating mechanism is migration, and it is being reported and followed by using ASTM 1202. So, like that, rapid chloride migration. So, migration coefficient is the durability parameter, migration or diffusion is the transport mechanism, NT build 492 is the standard available literature, that is code. Okay. So if we aware of these tests, and we give in the specifications for any big project or new construction, we define the grade of concrete should be this much, okay, in the design calculations, and we assume, okay, as if we are ensuring that the concrete grade is achieved. But are we ensuring the grade of concrete on the as-built structure? That is very, very important. And okay, before going to that one, in our specifications, in addition to strength, if we incorporate any one of these parameters, say for example, let us assume now metros are being implementing this RCPT as one of the durability parameters, so that during the mixed design itself, they are ensuring the quality of concrete in addition to the strength of concrete. So, what it is required at this point of time by the industry is the industry or the constructor or the owner of the project should try to bring some of these durability parameters into the specifications, okay, or the tender agreement, so that we can improve the quality of concrete. So whatever makes their the builder or the constructor or the contractor is going to use, that is immaterial to us, but the end product should ensure the RCPT value of this much, something like that. So why? Because now if we know something about the rebar corrosion, so I will talk something about the rebar corrosion. So reinforcement corrosion, as we all know that the rebar is protected or embedded inside the concrete. Therefore, it is being protected from the external environment. Okay, so that is why we keep the cover concrete depending on the uh, aggressivity of the aggressiveness of the environment. So that is why IS 456 gives a different cover thickness for different exposure conditions, whether the exposure condition is mild, medium, or severe. And also for fire resistance, we used to have good amount of cover thickness. And that is one thing, it acts as a physical barrier to protect the rebar from the surrounding environment. The another one is because of the surrounding concrete that is in very high alkaline environment, okay, the rebar will be protected by a thin passive layer. Because of the high alkaline environment, a thin passive layer will be formed over the reinforcement bar. So that we say, hmm, what is it? The passive layer. Okay. So that layer protects the rebar from further corrosion. But sometimes this passivation layer will get disturbed or damaged by a reduction in alkalinity due to carbonation or the presence of fluoride ions. So then the corrosion initiates. So here the corrosion is nothing but the interaction of material to its surrounding environment. So when the concrete is exposed to aggressive environments, for example, chlorides, the chlorides will enter inside and damage this passive layer. Then corrosion will initiate. And if the reaction is continuous, then corrosion progresses. So to continue the reaction, as I said, I will also again show in pictorial form. So we need moisture and oxygen. So that means the parameters that influence the corrosion process are cover thickness, quality of concrete in the cover region. For this only, we are going to evaluate the durability parameters. Quality of concrete, that is very, very important. Not only the physical cover thickness and the surrounding environment. So aggressiveness of the environment. So these three parameters mostly major parameters that influence the corrosion resistance performance. So corrosion mechanism. So as I said, rebar corrosion is an electrochemical process. So that means the flow of electrical current and the chemical reactions. So here the chemical reactions are anodic and cathodic reactions. Anodic reaction where the electrons will be liberated, and at the cathodic reaction that electron will be consumed in the presence of oxygen and moisture. So if you see this line sketch rebar embedded inside, so depending on the quality of cover concrete, voids or honeycombs, cracking, okay. So those places may become a cathode, and where the presence of oxygen and moisture will be there. And if there is any variability in the material, and anodes will form. So anode means at anode the electron will get uh, liberates, and that try to move towards the cathodic side, because the whatever the electron um, liberated, that has to be consumed, otherwise there will not be any reaction to continue. Okay, so therefore the important thing is either we can arrest the cathodic formation or anodic formation. And typical corrosion products, um, ferrous hydroxide, ferric hydroxide, and these products will again depend on the type of reinforcement bar and the surrounding environment, the aggressiveness of environment. And the main, I want to emphasize again the corrosion, how the corrosion is initiating and how it is progressing. So there are four essential requirements for corrosion cell or corrosion to continue. So that is anodic formation, cathodic formation, and a combination of this anodic and cathodic sides. So that means coupling of the anode and cathodic side. So here the, as I said, electrons and ions. Ions will be available in the pore water, whereas electrons means through the metal. So if there is a coupling or continuity or connectivity between anode and cathode, and presence of oxygen and moisture, the corrosion process will continue. Otherwise, there will not be any corrosion. So that is why if we make the concrete more impermeable and there is no oxygen availability, then we can very well protect the reinforced concrete structure from the corrosion deterioration. So elimination of any of these four requirements stop the corrosion reaction, so that make the reinforcement bar more and more good quality. So that is why some people will go for stainless steel, epoxy coated steel, okay, and galvanized steel. So thereby you are protecting the passive layer for longer durations. And these are the rust products. So different rust products will have different volumes. So because of the increase in volume of the rust product, so the rust try to exert pressure on the outer concrete layer, thereby cracking, delamination, and spalling of concrete will take place. So finally, you will see the exposure of rebar. So that is why the cover concrete is very important for durability of structural member, because that protects the reinforcement bar from the external environment, and also it acts as a barrier for the deteriorating agents not to enter inside the concrete. And this can be seen in a simple line sketch. So where the cover concrete that only is playing a major role in protecting the outside deteriorating agents to enter inside the core concrete. But In the design point of view, what we are essentially focusing on the core concrete. Okay, by doing consolidation and other things, compaction, we are making sure that the core concrete is adequate uh, to gain its strength. But whereas the cover concrete, we are not giving that much importance. But for the durability, from the durability point of view, we have to give equal importance to the cover concrete. So delaying of cover corrosion process, increase the cover thickness, but that increase also not uh, uh, what can I say? Without any limit, you cannot increase the concrete, but because we know that concrete is poor in tension, so therefore, whatever you are providing as per the codal provision, make sure that the cover concrete is of good quality. That is where the impermeability word will come into picture. And if you make the concrete impermeable, indirectly you are increasing the resistivity of concrete, the resistance of concrete from the electrochemical point of view. I'm talking this electrical resistivity because, as I said, corrosion is nothing but the flow of electrons and ions. So if we make the concrete impermeable, the ionic flow will get delayed. So this is where in this line sketch you can see the ions move from anode to cathode or vice versa through concrete pore solution. So if the pores are less interconnected, then the resistivity will be more. That is nothing but the permeability will be less. So you can see here. So as I said, the presence of oxygen and moisture is essential for corrosion to take place or to continue. So if we make the concrete impermeable, all these things we can take care of. That means we are increasing the resistivity of concrete and we are minimizing the entry of deteriorating agents like chlorides or carbon dioxide or the entry of oxygen and moisture. So as I said, two major corrosion mechanisms. One is carbonation induced corrosion. The other one is chloride induced corrosion. So in carbonation induced corrosion, what is happening is the outside carbon dioxide will react with the uh, water that is available in the concrete pores and will become carbonic acid. Okay. So that means if we make the concrete impermeable and less voids, the water will not be available, whatever required for the reaction or the formation of carbonic acid. So once the carbonic acid forms, that carbonic acid reacts with calcium hydroxide that is available as hydration products and then develops calcium carbonate because this calcium carbonate is in acidic nature. Okay, and then the pH of the concrete will come down from actually many of you may be knowing that concrete is very alkaline material, very high alkaline. So because of this carbonation, its pH will come down. So when it drops down 10 and below, then the passive layer, what I told earlier, will become destabilized, depassivated, and that will not no more. It will be available for protection of the rebar. So this is the phenomena of carbonation induced corrosion. That means the concrete when it is exposed to industrial environment or um, carbon dioxide exposure conditions, the CO2 try to enter inside the concrete and then it reacts with the concrete and the pH will drops down and you can see a more uniformity type of rebar corrosion. But whereas in the case of chloride induced corrosion, it will not be like this. So there a pitting type localized corrosion we can see. So here in the chloride induced corrosion, this is the uh, mechanism that is taking place. So first chlorides react with ferrous oxide, that is passive layer, and will become ferrous chloride. This is soluble in pore solution. Then the passive layer will become unstable, depassivates, and corrosion of steel starts. and later formation of rust products. So in the chloride-induced corrosion, it is more localized. Wherever the concentration of chlorides is more, there the rebar will get corroded. So it is more localized, fitting tight. Okay. So having known these things, again I'm going back to the specifications. So why the corrosion is taking place? Why these deteriorating mm, mechanisms are uh, coming or taking place in the concrete? So mainly inadequate acceptance criteria that we are adopting as of now. So, in addition to the strength, we should able to know whether the concrete has achieved the desired quality or not. Strength is fine. We were assuming that once we ensure the strength, it takes care of the other parameters like concrete quality and others, but it is not directly related because of the things that we are practicing at site. Because many times we don't maintain good cover concrete, and why we are not maintaining a lot of constraints will be there. When we talk to the site engineer, he will tell a lot of things. Okay, but at least if we are aware that the durability is mainly because of the entry of outside agents, and that can be restricted by making the cover concrete more quality and adequate thickness. So then at least we will take care, some care. So there these performance-based specifications will come to ensure adequate quality performance of concrete mix. So this can be taken care during the initial mix design also. Okay. So that means in addition to strength, some durability parameters need to be considered during the selection of a particular mix for specific exposure conditions. Because all the durability issues we have to take into account what is the surrounding environment that the structure is going to expose, whether it is chloride induced corrosion. Say for example, marine environment means chloride induced corrosion, industrial means carbonation induced corrosion. Sometimes both industrial and marine environment will be there. Whatever be the deteriorating the environment, the impermeability of concrete and provision of adequate cover concrete will takes care of. So durability performance specifications, we based on our SERC's experience, as I was telling. So a performance criteria is proposed when a concrete is exposed to chloride induced environment, RCMT, rapid chloride migration test, in addition to minimum compressive strength and concrete cover thickness. So I am keep on telling concrete cover thickness is very important because that acts as a barrier and also allows not to enter the deteriorating agents inside the concrete. Okay. So to ensure that, so we are putting two parameters in addition to the evaluation of strength. So one is rapid chloride migration evaluation. The other one is adequate cover thickness, concrete cover thickness. So nowadays, a lot of NDT equipments, portable, what is it, the profometer or cover meter is available. Many people are using that one. So if we use on-site on as-built structure by performing these tests, of course, cover meter means on actual structure, but during the mix design, we can do this test, this RCPT test, in addition to the strength test. Okay, and this cover thickness is on actual structure. So if we make these performance parameters, okay, so I am fixing my parameter, the RCPT value should be 2 to 8 or up to 8. Then I say the concrete is of, I am ensuring that the concrete is of good quality. Okay, in addition to ensuring the strength of concrete. Okay, and once the structure is constructed, I will ensure the cover thickness. What is the cover thickness? I put in the design drawings and what is available here. Okay, so if the cover thickness is not available as per the design requirement, then again, similar to this, these values, we have to give some classification. Okay, so then based on that, we can either instruct the contractor to take appropriate measures to take care of the the inadequate cover thickness, and also to take care of the quality of concrete. Suppose that means we may ask that fellow to either apply some protective coatings if he is not maintaining adequate cover thickness as per our specification or as per our design document. Okay, to understand more, to easily understand, I just give this case study details in just, I think I will take 5 minutes. So this is a precast RC box units for road bridge. One agency is the owner, and it asked to get the box units, reinforced concrete box units for road under bridge. Okay, and this is the dimension of the box unit, and this is the photograph you can see. So this is the box unit. So if they connect all around 12 box units, I think that will be sufficient to pass through the road over bridge. So what happened is the agency, the contractor constructed these box units, and in between there was some dispute between the owner and the contractor, and it could not, the road under bridge could not get completed on time. So the box units were exposed on site, and later the agency, the owner, want to reuse these RC box units for construction. So from the design drawings, the cover thickness required is 75 because the exposure environment is such an aggressive environment. It is both marine and industrial environment. Okay. So when we went for thorough investigation, because the agency came to ACRC and requested, means to take to get the opinion, because the uh, box units are laid there for 6 years or more, whether we can use these box units or not. So we did detailed investigation, and these are some visual observations. You can see a lot of honeycombs, and the agency told that they have ensured the strength of concrete as per the design requirement. So a lot of honeycombing. Some places rebars get exposed, and some places we observed cracking along the. Yes, please. And we also did the non-destructive testing, ultrasonic pulse velocity, cover thickness survey, core sampling, carbonation depth, and we also uh, got the concrete strength is passing or as per the design drawings. So UPV values, ultrasonic pulse velocity values, some places giving very low values, okay, and some place, most of the places it is giving good, but at few places the velocities are very low. And this is the cover thickness profile, you can see, and different box numbers, and faces, east face, west face, south face, like that. We made a grid and we measured the cover thickness. So some places, for example, box RC box unit 5, very low cover thickness, that is 5 to 15 actually the required is 75 So this is where the durability issue will come. As we know that the reinforcement is not protected adequately, then the corrosion will initiate very, very soon. So this is what we observed. Though we follow the existing the codal specifications, because the code is not saying, only code says okay, provide adequate cover thickness, but how to ensure that one, that we are not ensuring on site. So these durability parameters, this durability performance criteria will try to bridge that gap. And as I said, compressive strength found is okay, and carbonation depth we evaluated. Because of the voids and honeycombs, poor quality, inadequate cover thickness, the carbonation entered inside the concrete, and some places it reached up to 32 mm, and places where the cover thickness is very, very low, there the corrosion already initiated and cracking started along the reinforcement bar. So that is where the importance of cover thickness and the quality of cover thickness. So this is what the observations. So there are some voids and honeycombs and also inadequate cover thickness. And because of the variability in the concrete quality, the UPB values have been varied. And rebar corrosion observed in some places where the cover thickness is very, very low. So that means this study emphasizes the importance of concrete cover thickness for corrosion protection of rebars. And based on these tests, we gave the recommendations that the RC box units can be used, provided some precautions have to be taken where the cover thickness is very, very less and where honeycomb voids are there. There, they have to, we asked them to go for the protective concrete, protective coatings. Those coatings will try to act as a barrier for the entry of moisture and oxygen. And some places, as I mentioned earlier, some criteria given, but some places people will not allow us to take the concrete samples from the concrete. So they simply say, no, 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 RCPT means we have to extract the core sample. Even for RCMT also, we have to extract core sample. Or even if you want to evaluate the concrete strength, we have to extract the core sample. But sometimes it is not possible to take the samples from the actual structure because it will give some minor destruction locally and also will give bad appearance. So there you may have to go for non-destructive, fully non-destructive test where you can use the cover thickness as one of the parameter and ultrasonic pulse velocity as one of the parameter. And rebound hammer also can be used, but if you want to know, ensure the integrity of concrete, quality and integrity, it is better to use this UPB test. And here in this RC box units, we tried, we followed this type of classification. If the variability in cover thickness is plus minus 10%, then we say the durability performance is excellent. And if it is plus minus 20, it is very good, and if it is plus minus 25 it is good. If it is greater than 25 plus minus, then we say the quality of construction is poor. So accordingly the contractor has to take appropriate measures. Or suppose for example if the construction is very long, like bridge girder or the underground tunneling, a metro construction, so you take at regular intervals these measurements and you monitor how the construction is going, and off and on you can give the instructions to the contractor. Okay, your quality is not good, take appropriate action. If not, you have to uh, what is that, pay for that. So that means we can apply the penalty also, it means reducing the payment to the contractor or ensuring the quality. The idea is ensuring the quality of concrete. So with this, I will try to close my presentation. So what I discussed is the fundamentals of concrete durability, transport mechanisms of concrete, and different durability tests and the parameters and corrosion mechanisms and corrosion control measures, the durability performance specifications, okay, and case study emphasizing the importance of durability specifications. So with this, I will close my talk, and I think I'm happy to take one or two questions. Thank you.
Chris, you may please
Hello.
ask.
Yeah. So is my presentation was okay? You didn't find any audio problem, no? Audio or video?
No, sir, it was quite good and
Okay.
audible, sir. No issues.
I think I maintained timeline also.
Yes, sir, absolutely.
Yeah. So anybody would like to interact for any
Sir,
general?
I have a simple question, sir. Like,
Yeah.
in how much of these tests have been incorporated in the or a mandatory as like that in the codal provision or something, sir?
You see, codal provisions it has not come, but again, code means it is a just like guideline only. It is not mandatory. So as a
That I can
owner,
understand, sir. But the thing
as a
is,
owner,
uh,
when we are giving our tender document, tender specifications, there
yes,
we
sir.
have to bring in. There we have to bring in. So strength we are telling, okay, it should be M40 grade concrete. But
Okay.
whether it is cube based strength evaluation or on site as built
Core based.
structure,
Yeah, core.
that if we mention clearly, then I think 50% of the problem. That means here both are responsible, both owner and the contractor.
Okay.
It is not only to blame the contractor. What we
Okay.
want, we should be clear, and what we have to get from the contractor also we should be clear, and the contractor also should know.
Sir, one more doubt, sir. Like once you extract the core,
Hmm.
uh, it has to be refilled now, sir. Like
Yes, yes, yes.
so that can you just throw some light on it, sir? Like
Uh,
how to do
uh,
it?
at the earliest, it has to be closed with very dry pack concrete. That means very rich mix, means low water cement ratio concrete. It has to be filled. We say that is dry packing.
So once you do that, should we do some other test to find the integrity again, sir?
No, no, no. So here, that is what we should also know what type of test for what purpose. If you want to evaluate the strength of concrete, okay, uh, if the structure is very big and also the what can I say, the sampling is very important, and also the type of tests what you want is also important. If you want to know the quality and integrity, okay,
Yes, sir.
core is not required.
Oh,
You can go for the ultrasonic pulse velocity test or the rebound hammer test also. To some extent, it will give the surface quality of concrete.
okay.
If
Okay,
you
sir.
really want to know the strength of concrete, okay,
Okay.
and then you please extract cores, and that again depends how many samples you have to take, okay. And the core will be normally for strength evaluation we take the inner part of the concrete,
Yeah,
okay.
okay. Okay.
But from the durability point of view, we have to take the surface or the cover concrete only,
Yes, yes.
because that represents the cover quality of concrete.
Yeah, quality deterioration cover we have to take.
Yes.
Yes.
So that core sample can be used for the rapid migration test or chloride permeability test or oxygen permeability test. Whereas if you want to know the strength of concrete, you please take the inner core of the concrete.
Okay. Okay. Right.
Okay. Any other question? Have you visited SERC anytime?
Myself as sir.
Okay, okay, okay. Fine. So here a lot of facilities, and we often conduct courses also, especially on this concrete durability and uh, the testing methods, and other courses also being organized.
Yeah, one such I have attended,
Okay, okay, fine.
conducted by Smita ma'am as well as Ramchandra Murthy sir.
Okay, okay.
So participants, please.
Yeah. Anybody, any participants would like to know anything, or else we can close. If anybody would like to.
Yes, please. Sahi ma'am, are you there? Hello.
Thank you, sir, for your innovative talk.
Yes, please.
Thank you, sir, for your innovative talk.
Okay. Thank you. Thank you.
So from the Department of Civil Engineering, we extend a warm thank you from and regards for
Yeah.
enlightening us, sir. And do visit our institute once when you're free. We'll just contact you, sir.
Sure. 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 Thank you.
Thank you
Thank
once
you, one
again.
and all.
Thank you.
I'm just signing off. Okay.
Yes, sir. Thank you very much,
Next
sir.
section
Yeah.
starts. Next section starts with 2:30 p.m.
Pardon? I am not able to hear you.
So it is pertaining to the next session, sir.
Okay.
Thank you.
Okay. Right. 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 Fine.
Yeah.
Good afternoon, ma'am.
Noon. Good afternoon. Am I audible to you?
Ma'am, can you please? Yes, ma'am. Ma'am, can you please share your PPT?
Am I audible to you?
Yes, you are, ma'am.
Okay. Right. I'll do. Is it visible?
Yes, absolutely, sir. But is it in the full screen mode?
Now it is in the full screen.
Uh, I think it's not. For us, it is not, ma'am.
Okay. How how are you now able to see it in
It,
the
it
slide
is
mode?
it is not in the full screen mode. We
Huh?
can see the slides moving. That's it. You can share the
Now
full screen.
I have gone to slideshow.
1 minute, ma'am. Just wait.
Stop
You
sharing
have
mode.
Elba, please. Elba, are you there?
I'll do it once again. Huh?
Yeah, you can share your full screen
Yes,
also, ma'am. That is share your
Ah,
entire
yes.
screen.
to share the screen, you can see and also as share screen. You have to select that. Ma'am, now you can see.
Is it visible to you now?
And
Ma'am,
I cannot hear you clearly. Is my voice clear to you?
Yes, ma'am.
So your voice is breaking actually. Is the screen visible to you now? Full screen mode?
It is correct. It is in full screen mode.
Hmm.
Ma'am, it is not now in full screen.
Ah, I was just about to turn off the camera.
Okay, ma'am.
That is why I minimized it. I hope it is visible now.
Yes, ma'am.
That will do. At what time we are supposed to start?
Ma'am, 2:30.
Fine.
I think we can start.
Okay.
Hello.
Ah, yes.
Yeah. Sahi ma'am. Yeah.
At the technical
You are-
section, modern construction society Nagpur. Miss Vaidehi took her BE in Civil Engineering in MITS and her ME in Construction Technology and Management. She has also secured doctorate degree from VNIT Nagpur in 2015. She is a life member of Indian Courses Institute, Institute of Engineers, India. She mainly focuses in the area of sustainable construction, carbon emission through buildings. She has more than 15 years of both teaching and industrial experiences and also participated and presented papers in various conferences. Once again, I heartily welcome you, ma'am. Over to you, ma'am, for the session.
Yes, thank you. I hope this is visible to everyone.
Yes, ma'am.
Yes, ma'am.
Okay. So thank you, TOCH Institute of Science and Technology, to for giving me this opportunity to interact with the participants. It is very good that we can interact online. That is why we are able to connect to a very long distance. So the uh, talk was basically on sustainable construction material. Now, I would like to hear from the participants that what type of sustainable construction material you are aware of. One or two, just for example. I hope organizers allow participants to unmute and answer.
Yes, ma'am. They can.
Okay. So please give me some examples of sustainable construction material. Then I will move forward.
Ma'am, using mineral admixtures like fly ash, GGBS, etc.
Okay, that's very correct. Fly ash, GGBS, we call them as a sustainable construction material, right? There are many more. In
Ma'am,
concrete,
natural materials.
for example,
Natural materials.
natural, everything is natural resource. Just if one particular example of natural material.
Yeah, bamboo is one such.
Bamboo. Okay, so without wasting time, I will move ahead. Now we'll keep this thing in mind that we are aware of these type of sustainable construction material. Then what is the new point of view in this? If this is a so over talked, overdone subject, what new we can hear in this particular topic? So I'll try to give you a different approach towards sustainable construction material. I'll go through the content of overview of sustainability, which we are probably familiar with. Then there are some sustainable development goals. What is the need of drafting these goals? Then what are the different attributes of sustainable construction material, which comes under reduce, reuse, recycle? And then there are what different types of sustainable construction technologies. Even though technology we are not taking into title, how this technology is related directly to the sustainable construction material. So to start with, conventionally, as sustainability is defined as the approach that meets the need of present without compromising the ability of future generation to meet their own need. What needs future generation will find. So future generation will always find a need for development. They will want to develop their infrastructure, they will want to develop their lifestyle, they will want to make their work easy, and they will try to put lesser efforts on whatever they are doing. For that, probably to a remote area, now my need is to have a good conditioned road where I can drive, save my energy. Probably in future, my people will want to have a good type of airport or a helipad where the time can be saved. So their need will be different from my need, but sustainability gives a freedom to both the generations to use the resources judiciously. If you are, please mark the word judiciously, because if you are doing it judiciously, then only you can say that this is a sustainable approach. So we have three different angles into this. First is the development. I will try to develop the infrastructure so the economy develops. This is a well known relation between the two. So I develop the infrastructure and the economy of the region develops. Then in this whole course of the work, I harm environment in one or the other way. So if I am trying to develop the infrastructure for boosting up the economy without harming the environment or preserving the environment, I call my approach is a sustainable approach. And we are talking about sustainable construction material. Construction activity has a prime role to play in all these um, domain, or all, we can say all these course of work. There is again one definition which has one more angle, which is social condition. Economic environmental is already there, but it is the social conditions in which all of the society has the capacity and opportunity to maintain and improve its quality of life indefinitely. There is a conflict between developed countries and developing countries for who emits more carbon, whose lifestyle is less sustainable. There is always the thing is that developed countries, they say that developing countries are consuming too much of resources, emitting too much of carbon, making everything non-sustainable. And we say you have already approached to a threshold and you are using that resource. You have already consumed the resources, and now your lifestyle is set to such a particular stage that without energy you cannot do anything, and that is why energy equals to emission. So it means if you try to become sustainable in this, try to adopt that sustainable approach in this society, then you are supposed to put the social conditions as well, right? But without degrading the quality of availability of natural, economic, and social resources. So this is the definition. We will look into the sustainable construction materials with this particular point of view. What is a need? The need is, I say that my future population is going to use it. They are going to use it judiciously. And the need is that the population is increasing, and so the consumption. And I would say that the rate of increase of population and rate of increase of consumption of resources are not same. So it is not one on one. It is rate of increase of population is lesser than the rate of increase of consumption of resources. So we have a lifestyle, or we have a certain type of work where we consume more resources as compared to our ancestors. Now, in if you say in past 50 years we have grown around 5 times, this is a much greater rate than the forecast. And at the same time, the consumption rate of resources is much greater than, right? From where we are taking our resources, all resources, may it be our construction materials, may it be our energy, may it be our food, may it be our water, everything we are taking, or may it be a land resource, everything we are taking from the earth. That is why we are now trying to find out a suitable place to live rather than the earth. We are trying to move to the moon, and we are trying to find out whether the moon supports us for our living, so that now we can leave the earth and live on the moon to make it no more sustainable. So if there is a balance between the demand and the supply, we say yes, the balance is, if the balance is struck, then it's okay. But if it is not, then supply is lesser, demand is much faster. In this whole process, every process has a certain type of waste. Some processes have more waste, some processes have less waste. For example, our lean construction principle says that when there is a waste, the waste should tend to be zero in any particular activity. So sustainability also says the same thing. WRE says that production waste are increasing in spite of increasing efficiencies. Manual work, mechanical work, or automatic work, you cannot compare them, but at the same time, the wastage is increasing. So every activity a human is doing, it is going to affect the ecology of globe in one or the other. Now let's compare the two types of population, a rural population and an urban population, where We know that urban population will be the prime consumer because they consume more energy because their processes are different, mechanized and different. What is an urban population? So urban population is nothing but a geographical boundary where production is less, or production of resources we say is less, but the consumption of resources is very very high, and the more or less it is because of the mechanization of that particular population. Right, there are too many social angles to it. It's a wealth, it's a lifestyle, it's a political status, it's the ULBs, etc., etc. If I say more population is coming under the category of urban, does not mean that the people are migrating from rural to urban. Here I mean to state that the area which geographically earlier belonged to the rural, now because of the development in infrastructure, it is taking shape of an urban body or urban region. Am I correct? My village develops, it has road, it has water treatment plant, sewage treatment plants, industry. What will happen next? What do you think? I need answer on this. Can you hear me? Am I audible to you?
Yes, ma'am, you're audible.
See, biggest disadvantage of sharing the entire screen is I am not able to see your messages because I can see only my screen. Otherwise, you will be able to see only a part of screen. And if you are not talking to me, I will not understand when I have lost connection. I will keep on continuing talking. So please, when I'm asking something, please make it sure that you respond. Maybe a very short answer. Okay. So I was asking you that if my village grows and it becomes urban, always it is possible. Will it happen that yes, I am becoming sustainable and urban? Urban population does not mean it's growing urban population does not mean that the rural people are migrating to the urban area. On the contrary, it also means that the rural areas are developing, more mechanization, industrialization is happening, and that particular population now comes under the urban body. And because now they have adopted a lifestyle of a urban population, their consumption of resources will increase. Is that correct?
Yes, ma'am.
Okay. Now you may think that we were supposed to talk on sustainable construction material. Why this particular point has taken up is sustainable construction material is not a very innovative or a new material. It is an approach you see to a material from the sustainable point of view. Right. So if you say that a certain material is a sustainable material, it should be sustainable throughout its whole life, or the life cycle sustainability has to be there. So if we don't bother about, Earth will balance all this energy, all these disturbances on its own. It has some networks. There are some connections between life and planetary system. There are some cycles. The Earth has decided that yes, this cycle will be there. Now we say that the plastic is a non-degradable type of material. It is a non-sustainable material and we cannot use it. But there are some researches which are showing that you can use plastic to generate fuel. You can use plastic to generate fuel to use or to power some process. It means it has some utilization on the earth, right? So earth makes it sure. But if our rate of disturbing it is greater than earth balancing it, then naturally it will result into something very disastrous. So as you can read on this, we know that there is global warming, there is carbon footprint, how we connect these two things, that is known to us. My point is, everything can be sustainable if you look into each aspect of its life. So there is nothing innovative or new thing which you will call this as a sustain. You will call fly ash brick as a sustainable material. You will call red clay brick is a non-sustainable material. I have a different point of view for that. I say fly ash brick is no more sustainable. The answer to my first question was, what is a sustainable construction material? So ma'am said that yes, fly ash. Now I say, if fly ash is a sustainable material, should I be producing more fly ash because it is a sustainable material? Or should I be shifting to such a process which generates electricity without using coal? What do you think? I will repeat my question. If fly ash is a sustainable material, should I be producing more fly ash using more and more coal, bituminous coal in making electricity so that I can generate more fly ash because it is a sustainable material? Or should I be shifting to a different technology to generate electricity so that the fly ash generation is reduced? Which approach is more sustainable? What is your answer on this?
Second one should be the answer, sir, ma'am.
Right. It means this point of view says that fly ash is no more a sustainable material. We make it sustainable because it is a wastage of some particular industrial production process, some particular process, and we are utilizing that for conserving the natural resource. That is why we call it as a sustainable material. Right? So it means if you change the point of view, the definition of sustainable construction material will change. Simple example given is the paper cup. We say use paper cup because it is more sustainable, right? Because it is made up of paper. I say use a metal or a ceramic cup, even if it is more energy intensive process to make a metal or a ceramic cup. Its cycle of usage is 1,000 times more than a paper cup, right? So in my point of view, the ceramic or the metal cup becomes a sustainable material because its life cycle overall burden on the earth is lesser. So that is how we are supposed to. When we perceive this particular approach to sustainability, then it was different. But now that we are going into a bigger research into this, the approach should change. I hope at the end of this session, probably because all of you know what sustainable construction materials are, I'm not going to talk about this insulation material and this fly ash based or mineral admixtures. This is all known to us. Everywhere the information is available. Information given in this slides also is available to you at your disposal. The only thing I want to highlight today is your point of view should change to look at a sustainable construction material. Now, what is the ecological footprint if we try to find out biocapacity deficit, biocapacity reserve? I was just telling you that the rate of consumption of resources should be equal to rate of production of resources by earth. If that rate is not matching, we are bound to use crusher dust. We are bound to use manufactured sand because natural sand is not available to us. So in that case, I cannot call that crusher dust or the manufactured sand as a sustainable construction material. It is not. I am bound to use it because natural sand is not available, because rate of consumption of natural sand was very, very high as compared to the rate of production or formation of that natural sand in the riverbed. So I'm bound to use it. Now, it may be costly for me, it may be a non-sustainable processed material for me, right? But I will try that whatever reserves of natural sand are there, they are preserved and they are not disturbed. So this is the ecological footprint which I am talking about, is how fast we consume resources and we generate the waste. And we do two things: we consume the resources, as well as in that process we generate the waste also. That waste also, earth has to do something with that particular waste. The earth has to consume that waste because it's a cycle. Everything in the earth goes in a cycle. So I am consuming something, I am producing something, that the thing which I am producing, earth is supposed to again push it in some particular cycle, right? So this ecological footprint is calculated by, is usually measured in global hectares. Global hectares, because that much of area of earth I will be contaminating by doing some one or the other process. If my rate of consumption is higher than the rate of production from the earth, I call it as a biocapacity deficit. If my rate of consumption is lower, then it is a biocapacity reserve. Which material I will call as a sustainable construction material? There are two parameters associated to it. One is it requires lesser energy, or as low energy material as I can find, or it is as environmental friendly as I can find. So construction is the biggest factor which causes, we can say it's the biggest factor which causes, uh, nowadays in our country we say it is the highest activity which is going on, because of which we can say that the global warming will be there, right? Now, because to make one particular construction material, for example cement, there is a whole industry or industrial, a process is there where the huge industry is involved. If you see the top right figure, you find that you require, you emit some CO2 while extracting the limestone. Then you bring it to the plant. You require some energy to crush it. You require some fuel to run that rotary kiln where the cement clinkers will be produced. Then you package the cement, you transport it to your dealer. You require some fuel to transport it to the dealer. From the dealer, it comes to the site, you require some fuel for that also. You require some fuel to make a concrete out of the cement which is there. In this whole process, by one or the other means, what we are doing is we are emitting the CO2. So if I want to achieve the sustainability in the cement, not only the raw material utilized for the cement is to be looked upon, but at the same time, the energy or the emission throughout the transportation of the cement from its source to its consumer is also supposed to be looked upon. So there is emission, there is reduction, there is zero carbon. If there is zero carbon, we call that as a material or a building. Building, I have written here building, but it can be a material also. It's a carbon neutral. If it is more, then we call it as a carbon plus. And if it's sequestering the carbon, if it's absorbing by some particular means, then we call it as a carbon minus. So there is a systematic approach to achieve all these things. Are you aware of sustainable development goals? Have you seen this picture before? Any one of you?
Yes, my SDGs we are aware about, ma'am.
Okay, can you tell me which particular SDG is to construction industry? Out of the 17, which particular SDG is directly related to construction industry? Okay, I will tell you. No issues. If you look into this is for social well, something is for individual well-being, something is for global well-being, and something is for societal well-being. For example, individual well-being, I can say peace, justice, strong institutions. Individual well-being, I can say no poverty, quality education for individual well-being. Then societal well-being, peace, justice, and strong institutions is there. Then decent work and economic growth is for global well-being. Accordingly, there are some sustainable development goals we can relate to the construction industry, and the target is to achieve these SDGs. SDG is written, it's SDGs is to make our construction industry more, I mean, to achieve the more sustainable processes in our construction industry by utilizing the sustainable construction materials. That's true. So Six SDGs that are of particular relevance to the construction industry is we see the life cycle of a building. So for life cycle of building, the first resource which I require is the land. If I require the land, the sustainable development goal which comes into picture is the sustainable cities and communities. There is one more phrase or term being used nowadays as a smart city. Now, smart city actually is a sustainable city or not, that's a different question. So I have land. I cannot produce land. I can reclaim it, but I cannot produce land. So that is a non-renewable type of resource as far as this life cycle is concerned. So if it is a non-renewable, so I cannot produce it, then the rate of consumption of that land should be lesser than the rate or the availability of that particular land. Right? Second thing is, second SDG comes into picture is industry innovation and infrastructure. For every industry, I will require some resources. All resources we source from our Mother Earth. Everything, whatever we require. Water being the major resource. Rocks, natural deposits, minerals being the other resources. So if I want to grow in infrastructure, then I am certainly consuming the natural resources, natural deposits. So rate of consumption of that natural deposit should be lesser than making a natural deposit. Now you know that if I am cutting one particular hill or one particular rock deposition for making my aggregates, then I cannot make them again. It will take thousands of years to create such deposits. Certain processes without which I cannot create them. I cannot create them. Earth is going to create them, right? So that rate of consumption should be less. Then third SDG is building material, where I say the responsible consumption and production should be there. I will repeat here. We cannot claim that a certain material is a sustainable construction material. If anybody does it, then they are supposed to find the whole life cycle sustainability of that particular material. Because sometimes a non-sustainable material, for example, natural aggregate, if I'm using it very, very less in my designs, I design in such a way that I require a very less amount of that material by improving upon the strength of the component. Then I say that yes, I have achieved sustainability in this whole process. Right? It is not necessary to call that particular aggregate as a non-sustainable resource over there. Then clean water and sanitation, affordable and clean energy in the usage, say, phase, and climate action. Everything is related to one particular phase or step of the life of the building. This is the current scenario. You can read the bottom line is you extract, you process, you assemble, and you waste. Wastage cannot be eliminated. It can be minimized. Every process, when there is a transformation of state of the material or the phase of the material, there will be certain waste. Right? Now we know that there is a law of energy conservation. Now, so in someone can say that there is an energy conservation law. Similarly, there is no material conservation law. You are bound to waste something. The only thing is degree of sustainability you achieved directly depends on the degree of waste you minimize. Okay, now what can I do for all these things? So raw material consumption is increasing and it will nearly double by 2060 under a business as usual scenario. Overall commercial scenario, if you look upon, we are now of a mindset that use and throw. If you cannot give it a good life, that material is not sustainable material. I'll give you an example of if you are doing a false ceiling in your house, if the life of your structure is 60 years, ideally that false ceiling should also live for 60 years. You will maintain it properly, but it should live for 60 years. Now that is insufficiency of material property that you cannot design such a durable material for that particular purpose. And okay, but in a certain building or structure, if different materials have different lives, then the overall durability of structure will be compromised and the whole process will become a non-sustainable process, right? So these many are the problems associated with the building materials or the construction materials, and which makes them a non-sustainable construction material. So how can we control it? Two types of energy or two types of emissions or carbon emission will be associated to any particular process or material. What are those two types? Two types of energy associated to any material. First is embodied. What is embodied energy?
Energy that is associated with overall process, like starting from the raw material till the product.
Okay, so cradle to gate, when you receive that material, the energy which you use, and the emission, which is the carbon which is emitted in this due process, is known as operational. Now, to check the sustainability of a certain material, embodied energy and operational energy, these two should balance. If there is a material whose embodied energy is very, very less, but whose operational energy is very, very high, means a material which is not thermally insulating material. Embodied energy is less, but when you use that material, you require higher operational energy to maintain the occupant's comfort inside a built environment. It makes that particular material as a somewhat non-sustainable material. But if the embodied energy is high and the operational energy is low, and same in the case of carbon, then you say that yes, this material has become a sustainable material. So there are basically three approaches to this thing. You can see here that work of the geobiosphere raw material management is to be done. Use as low or as less as material, as less as you can. Use least material which is available on earth or the resources. It means reduction at the source itself. Reduce the requirement of material. Then in case of production, when you are extracting it, extract that you so that you don't harm the environment. Transport it energy efficiently. Manufacture it. Achieve a process of manufacturing where there is least of the waste generated. Do off-site prefabrication. So on-site fabrication is reduced. For example, we do the precast and all, or 3D printing and all. So off-site fabrication or on-site advanced technology fabrication. Same is with the construction, same is with the use. In use, I would like to draw your attention to two things. One is repair and refurbishment, second is the ongoing maintenance. If you don't do these two things, you reduce the durability of structure, and whole of the sustainable material which is over there becomes a non-sustainable material because it has not lived its complete life for which it was designed. And end of use, when you are doing this thing, you deconstruct, right? Deconstructing is different than demolishing. Deconstructing means finding out or extracting the usable material from that building which is of no longer use to us in proper shape and size so that you can directly put it to reuse. Reuse, recycle, redesign, incinerate, and after all these processes, if there is some very little amount remaining which you cannot do anything about, landfill it. So our concern is very high energy materials, high energy materials, medium energy materials, low energy materials. If I look into very high energy material, the quantity of these material which we use in construction is very, very less. So I'm not bothered much about it. High energy material where the cement and steel comes over, the quantity which we are using is very, very high. Second is the medium energy material where all the types of blocks, masonry blocks which are coming into, and concrete coming into is a medium energy material, but the quantity is very high. So concerned about it. And low energy materials are there because you need only extraction energy from this. Sand, you need only extraction and transportation energy. You don't have to synthesize it. But then use is very high. So for a sustainable construction or to call that material as a sustainable material, I'm supposed to look into second, third, and fourth more judiciously. Okay, now come to the topic. So everything has to be a whole life cycle approach. For this whole life cycle approach, nature is our guide. So in nature, there is no waste. One material is food or raw material for the other one. We can explain it simply in the say we call it as a biomimicry, where bigger one is going to consume the smaller one, more bigger one is going to consume the bigger one, and the cycle will continue. Right? Similar word is there in now the economy. We call it as a circular economy. I am a producer. I produce and I only consume. So I am the consumer, I am the producer, so that the balance has to be struck so that there is no wastage in that cycle. But in construction industry, what happens is how we are making that particular building, or we are using consuming the resources. In each of the processes, we are generating some type of waste. So in this process of construction, how can we make these materials more sustainably? It's not only about raw material. I will repeat. Someone said bamboo or wood based material. It's a very good material because we directly source it from our nature. Grows very fast, so supply is there. But if the land is very much restricted, I cannot go for a what I can say, I cannot go for a high rise type of construction with that. Right now I cannot. Maybe in future there will be some technology where I'll be able to. So now usage of land, that is horizontal construction versus vertical construction. If I am supposed to look into some material, I'll be preferring some different material than bamboo. Accordingly, for each of the step, I'm supposed to put into that equation for sustainable construction material. So 5 steps. First is extraction of raw material. So in raw material, if you want to call a material as a sustainable material, either you reuse some waste product out of some industrial process, or you recycle the used material in which you have already used in construction in some modified process. Then when you execute the construction process, either you do it off-site, or you do it modular, that is compatible, or you do it energy efficiently. Then when you use it, it should be low on operational energy. Here I am not talking about saving electrical energy. I am talking about the potential of a material to help you in saving the electrical energy. If your material has that potential, that it can help you in saving the energy, or your technology has that potential which helps you in saving that energy, that will come under the category of a sustainable material. Thermal insulating material, acoustic materials, these will come under the sustainable construction material, even if their embodied energy is high, right? So passive solar architecture is a method by which you can preserve that operational energy. Fourth is to maintain the phase of usage. If you don't maintain, the life will cut short, and then you will have to again use the resources. Same resources or different resources in making the same facility. So if you can extend the life of the structure, even if initially if you have used a you can say artificial material or a synthesized material or a non-sustainable type of material, but if the life of structure is very, very high, then you say, yes, sustainability is achieved in that material. Secondly, when you are maintaining it, repairing, rehabilitating, then use eco-friendly materials in repairing, rehabilitating. Last is when you deconstruct in such a way that reuse potential of the material, present material in that construction, improves upon. So this is a whole approach to sustainable material, a whole life cycle approach we call it as. So we have tried to touch each of these 5 stages. Maybe fifth is not completely done. 4, 5 stages. Let us see one by one what are the potential of each of the step, what we can do. Reusing waste as a potential raw material. Can you tell me what are the characteristics of the waste which can make it as a potential sustainable material? What can you see on this slide? Yes, to the right side on slide, how many types of industrial waste are visible to you?
Nine.
Are all of these sustainable material? When I will call this material as a sustainable construction material?
Most of these are waste products and can be used in one way or other. Is it because of
Right.
that?
Because it is an industrial waste, one or the other industrial process. This is an industrial waste. I can call them as a sustainable material. Conditions apply. The condition is if I am using these materials in the vicinity of their generation. Am I right?
Yes, ma'am.
Just because foundry sand is a waste, or bottom ash is a waste, or GGBS is a waste. If the source is too far away from my consumption point, then transportation emission and the transportation energy can make this particular material as a non-sustainable material. Am I correct?
Yes, ma'am.
So next time whenever I say that a fly ash or GGBS is a sustainable material, I have to mention that within the vicinity of its generation or the source. Now here you can see there is the extent of utilization given by our IS code. This is IS 383, which is the IS code for coarse and fine aggregates. This IS code has given us percentage maximum utilization for reinforced concrete and plain concrete. Then lean concrete. Now there may be a question why they have put a upper threshold for using or upper limit for using this particular type of material in concrete, making concrete, whereas all these material we call them as a sustainable material. Now there may be a certain case where if you are using this particular material, its characteristics, physical chemical properties do not match to the natural aggregate, so they are not able to produce the concrete as good as the natural aggregate produces. And because of that, the final concrete which you will be making will not have the proper disposal or utilization possibility. And that is why there is an upper limit for use of this material. So they are supposed to be used in a blended form. So we did one project wherein we used those foundry industry waste which they are generating. This is a project funded by one of our local foundry industry, Messrs. Kapilansh Dhatu Udyog. Excuse me. You can see they produce some 6 or 7 types of waste in their whole processes. There is one cupola furnace, there is one induction furnace. So they are producing slags from cupola furnace and induction furnace as well. And there are 2, 3 different types of sand they are producing. Actually, I should not call it as a different type of sand, but it is the sand produced in a different steps of that foundry process. So we utilized these 2 types of waste in making a concrete. Now, this material became sustainable construction material because the industry was located in our own vicinity and the transportation energy of that foundry waste to our site or to our laboratory was minimum. If you want to use this waste somewhere where the transportation energy is very, very high, this particular waste will not be a sustainable waste anymore. So we used the cupola slag. We crushed it because there were bigger chunks of say 150 mm, 100 mm, and higher uneven combinations. So we crushed them to bring it to the size of our natural aggregate, to the gradation of our natural aggregate. Then we use the reclaimed sand, which is the sand which is reclaimed in the process of mold for casting, and then through the reclamation process, washing and cleaning process, it is again taken out. The same sand is used for 2-3 cycles of sand molds, but after those 2-3 cycles it will come back to the waste. So these two things we used, made some mixes of concrete for M40 grade, and then we found that yes, we can use this aggregate. Cupola slag we can use 50% replacement of the natural aggregate, and sand at the same time we can use 30% replacement of the natural sand. So processing energy required for this particular material was calculated. For example, sand was available to us from the reclamation plant, so it was as it was used. For cupola slag, we required processes of crushing and sieving, and then we used it as a replacement of natural aggregate. But after that process also, we found that it is giving us good saving in the cost and good saving in the natural aggregate extraction energy, and that is why this becomes a sustainable material. The only point here was, as I told you earlier, the process of using cupola was modified afterwards, and at the point of generation of that slag or the waste, the process was modified and the waste generation was tried to minimize, and the cupola slag supply was non-sustainable. So whatever material was generated, that can be used, but this cannot be used for a long run for making concrete because there is no more material available with the industry now. They have changed their process. Similar scenario can be for different types of industrial waste. Okay, the next waste is, nowadays we are listening too much on construction and demolition waste. Everywhere there is, we are saying that natural aggregate is not available to us, so we'll go with the construction and demolition waste. So how much sustainable the construction and demolition waste we'll see is, everywhere you can see this is a global practice of utilizations of C&D waste. This utilization becomes very much essential where there is no further supply of natural aggregate. But C&D waste utilization needs to be more sustainable through its process of production, right? Because you require certain stages of production or processing for C&D waste to be utilized for making the concrete. Reiterating the same table over here, recycled concrete aggregate, recycled aggregate, these two definitions come for. Recycled concrete aggregate is the aggregate which you derive from the concrete, and recycle aggregate which you derive from construction and demolition waste. So what is the basic difference? There is a building. Say the building is composed of a masonry in walls, concrete in its frame, that aluminium, glass, somewhere some steel, structural steel, reinforced steel, etc., etc. You separate them out completely, and once you demolish them, the mix which you are getting has some part of brick masonry, some part of plaster mortar, some part of stone, tiles, etc., and some part of concrete. This mix is called as a recycled aggregate. This is a very heterogeneous composition of material, and therefore utilization of that particular material cannot be done as it is for reinforced concrete. Still, our IS code has the confidence that we cannot use it in reinforced or plain concrete because it will contain too much of ceramic waste in it. which is very, very porous in its nature. But recycled concrete aggregate, suppose you demolish a structure which has maximum concrete composition, for example, a bridge if you are demolishing, or if you are demolishing concrete pavement, then the maximum thing will be concrete, there will be no traces of masonry. In that case, you can use that, you will call it as a recycled concrete aggregate, and you can use that particular material up to 20% in reinforced concrete. IS code says that only up to 25 grade, but literature says that you can go to the higher grades as well. Now we'll see that whether this particular material is actually sustainable construction material or not. First point comes here that if you are using it only up to M25 grade, you cannot use it, as IS code suggests, you cannot use it in important type of components, right? Or if you want to use it in a component, if the grade of concrete is less, then you are supposed to give more dimensions to that particular component. So which uh, generates a need of utilizing more quantity of concrete in that construction. Okay, I'll skip this. These are the different Indian guidelines for utilization the construction demolition waste. Everywhere you will find that still they are not going into standard grades of concrete. They are going into only ordinary grades of concrete. Right. Another question in the sustainability of this particular material is, if you require certain processing for the material, whether the end material will really be sustainable or not. So if it is not, how we are going to call it sustainable? For what reason we are going to call it sustainable? So this is the quantity of generation of CND waste in approximation in the quantity everywhere. But in some particular cities, now they have started collecting it. Maybe in some future, we will have the exact quantities or the potential of generation of that CND waste across the regions. These are the sources. Source decides what type of waste you will be getting, whether it will be RA or whether it will be RCA. Separating out RA and RCA is very difficult. So can we use that RA as an aggregate? Here we can see three types of aggregate which we have used in one project. It's the tiles aggregate, another is the concrete aggregate, and third one is the brick aggregate. Combinedly, they were used to make a building unit or primary building unit. These are the processes through which the demolition waste has to go: segregation, crushing, screening, treatment, dust removal, and treatment. After that, some chemical treatment, some mechanical treatment. And after that, you will be able to use it. If you are using it without treating, you are not exploring complete potential of that material. So you're just replacing the natural aggregate by that. But if you are treating, you are putting some, or you are some energy will be required for that particular treatment. So this is the project of development of construction demolition waste bricks, where RA was used. Two types of bricks were produced. One was a hollow brick, another was a solid brick. And then the comparative analysis was done for hollow and solid bricks. In the solid bricks also, you know that there will be, in RA, there will be brick particles. So the thermal conductivity of that particular brick will be lesser. So if I want to call it a sustainable material, if the processing energy is more, then what I can achieve? So I told you there will be two components of that particular energy. One is the embodied energy, another one is the operating energy. So if reprocessing of material is requiring more embodied energy, then if operating energy can be saved by achieving a thermal insulation, then I say that I have balanced the sustainability characteristics or the requirement of the sustainability of that material to the natural material which is available outside. Okay, the next example is execution, low energy in processing. So we used some forestry and agricultural waste in building material, wherein we tried to prepare some panels out of bamboo and coir. Coconut coir was used as a fiber, and the bamboo was used as a continuous reinforcement and a filler material. Again, to call this material as a sustainable construction material, if I am consuming it at a higher rate than the production, it makes the material as a non-sustainable construction material. If my rate of consumption is lower than the production rate, then I can say that yes, I am using this material as a sustainable construction material. Secondly, the durability of this material should match the durability of similar type of material which is being used for similar applications. So it was a simple process. The bamboo waste from the bamboo processing unit was procured. It was brought to a size of filler 3 mm down. Then lime soil and some part of POP was used as a binder. Then coconut coir was used as a fiber, and the bamboo strips were used to create a mesh, and the panels were cut. Preliminary investigation was done on the cubes for compressive and uh, compressive strength, and after that the panel casting was done. And for these panels, the MOR and breaking strength was investigated, and it was found that 28% of bamboo as a filler gives the maximum breaking strength. Then the third point in sustainability of any construction material is if you can use a process which requires lesser energy. So in precast, when you make precast panels, pre-stressed precast panels, there is a requirement of we say vibration. So for small applications where you do not require huge mechanical strength, can we eliminate that particular energy which is required for vibration? Can we deploy such a technology where without vibrating we can make or manufacture panels, and we can use those panels to construct the small units? So this was a project taken up for a low cost precast toilet block with a self compacting concrete, using self compacting concrete for making panels. So it does not require the vibration energy, and the panels were casted, and with the help of those panels a toilet block was constructed, and the necessary mechanical and durability test on that panel were carried out. Okay, the next is to make such a material which is a very low on the operational energy, or a combination of material which is low on the operation energy. For example, if embodied energy is more, but I can make a thermal insulating material which requires lesser cooling energy, then the operational energy of that particular material will be lesser. So total life cycle energy will in turn reduce. So in this particular project, there were doubly glazed windows which were manufactured using the concept of double glazing and the cavity for insulation. The windows were so constructed that one pan of glass had UV resistant film on that, and another pan of glass was plain. Because in summer season, you require radiation cut off at the outside, and in winter season you require radiation from inside to outside, that cut off from inside to outside. So the windows were, we were able to rotate the windows with respect to what type of cutoff you require. As you can see in this building model, there is a model which was constructed for this experiment or this project, where we achieved good thermal insulation inside the building by using the double glazing windows. The glass used in this particular project was a normal commercial glass which is available in the market. Only the construction method of the window was little bit modified. Then for comparison of this particular technology of construction waste, construction demolition waste bricks and the windows, two models were compared. The model M1 had fly ash bricks and normal glass windows, and the model M2 had construction demolition waste brick. There was an insulating material on the roof itself and the windows with the double glazing unit. And while in comparing this, temperature were recorded for complete 1 year inside this built environment, and it was found that the we can achieve a delta reduction in the temperature using that double glazed windows, using that roof, as well as the bricks also. The same results were simulated on transit and were validated for experimental by the experimental recordings as well. So here I want to point out that if you say that if you are using RCA and you are putting some extra energy to process that RCA, because when you demolish a building, bigger boulders of RCA or concrete will be available to you. You cannot use them as it is. You can use them as it is only when you are dumping them somewhere. No, right, which is a non-sustainable type of disposal. So if you want to use it, you will have to crush it. If you are again crushing it, if you are crushing it, then you are giving some energy to that process. So it makes our demolition waste aggregate as more energy intensive material, which contradicts with the definition of sustainable material. So to make this particular thing as sustainable, we are supposed to change the technology of using that particular aggregate so that the operational energy is somewhere saved, so that the overall energy will be lesser. Can you suggest me more methods on this, or any doubt so far? Yes? No doubt? Okay, then I will ask you the doubts. I hope you are listening me.
Ma'am, I have one doubt.
Yes?
Ma'am, actually, if I'm using artificial aggregates,
Uh-huh.
so I can't just consider it as sustainable just because I'm using or making the aggregate from waste, right? I cannot
Right,
just say it is sustainable.
right.
Okay, okay. So it depends upon the process or the energy consumption and all, right?
So, yes, correct.
Okay, okay, ma'am.
So, how will you justify that when you are using the artificial aggregate, it is sustainable? That is what
Yes,
I want you to ask me, because I am
yeah,
posing this question since start.
yes, ma'am. That's my doubt regarding that.
That is what, see, when I was asked, or when I asked that, yes, I will present this particular topic, I could have I could have put all those sustainable materials which are available outside on the slides, right? So many of them are there. The bricks, blocks, mineral admixtures, and so on and so forth. I could have done that, but I did not want to do that. It is easy to call a material as a sustainable construction material. It is difficult to justify. When you are using, probably if you are doing your work on project on some industrial reject, what you are supposed to do to justify that, yes, this is a sustainable material for my project. That is what I want you to ask me.
Yes, that's exactly what my doubt is about, ma'am. I was
Okay.
thinking that if I'm using or converting something into a good material, I mean, if I'm utilizing the waste, then I can call it as sustainable. But after listening to your talk, ma'am, I was just wondering, it's not like that. We have
It
to,
is not like that. You
yeah.
can you see the slide now?
Yeah, yes, ma'am.
Right. So the slide says that You have a project. You have two, three different types of materials. One is the conventional type of material, whatever you get. So all conventional, see, in construction industry, conventional material are those material which are available in the vicinity always, right? Unless otherwise you want some fancy construction, everybody will try to use the material which is available in the vicinity.
Yes, ma'am.
Correct. Where there is a bamboo available, everywhere will try to use a bamboo in their construction. Where there is a different type of timber available, they'll try to use. If there is a particular type of stone available, they'll try to use it. This is the convention. We have been following this thing for long, right? Now, for new urban concrete gardens, where there is a fancy of utilizing some material, they will try to bring the material from far away and they'll make their building non-sustainable. That's okay. If you are just for the purpose of making your building sustainable, if you are utilizing some waste which is not available in your vicinity, then that makes the process as a non-sustainable thing. That is what I am trying to emphasize on. That is what I am trying to tell. How can you justify that? So now there are only two steps to justify it. First is what embodied energy is there for reprocessing the material you require. That is because I stated that you call fly ash as a sustainable material, but you should try that less of the fly ash is generated. Just because you are calling it as a sustainable material, you should not increase the generation of fly ash. That makes the whole process non-sustainable. Correct? Now, if you want to generate lesser of fly ash, use less of the electricity. So, electricity generation is requirement is less. Using electricity generation, less electricity or reducing the generation, use a material which gives you good thermal insulation. It's a very raw type of figure I am putting before you. Give a material which gives you good thermal insulation, reduces your operating energy and load on your electricity generation. And this whole cycle completes. This is the cycle. If your material fits into this cycle, now how you will claim that your aggregate, for example, my project basically is on construction and demolition waste. That's my area. So how I am going to justify that yes, construction and demolition waste is a sustainable material? I will tell you that this material requires this much of process energy, but if I don't use this material, I am supposed to use X quantity of natural aggregate which requires equal energy for extraction. Understood? Second,
Okay.
if I don't use this demolished concrete, I am going to utilize this much area of land for dumping it, making that land non-usable for any of the purposes. Where I could have planted this number of trees for carbon sequestration, absorbing that. Understood it?
Ah, yes, ma'am.
If I can do this type of calculations, then I can put in yes, utilizing this, even if it requires a mechanical crusher, even if it requires a treatment, but then the end use I have changed to make the process more sustainable. That is why my demolition waste is more sustainable rather than using the natural resource. This is more sustainable. That is what I am supposed to put into the definition of sustainable construction materials. This was done actually for this. We designed a small building to Excel based tool, which we named as CAMI Build, Carbon Minus Building Design Tool. If you remember the slide where I showed you carbon plus, carbon negative, carbon neutral, and we try to find out the comparison between two cases, is the base case and one is the best case. For each of the step in the whole construction, we tried to calculate the embodied carbon on each of the processes, where we utilized that we used the calculation for construction demolition waste bricks. If I utilize that particular material in a building construction, how much carbon I will be able to save. So accordingly, I reached to a decision that yes, if I use this brick which is made up of processed construction demolition waste, but it gives good thermal insulation because of its properties, thermal conductivity property, then this much operational energy will be saved and this material will fall into the category of a sustainable construction material. This is what the result sheet is. This is how you do calculation in that tool, and this is what the result sheet is. We can calculated the energy cost index, emission cost index. Cost sustainability is the major point in any of the material. You are supposed to achieve it. Okay, so probably the last one, because I was given the time up to 3:30, I exceeded 10 minutes. I'll try to wind up it. Last one is, if you want to make your process or material as a sustainable material, let the material live its full life. There should not be any premature replacement of the component of material. Otherwise, the whole process becomes non-sustainable. So how we do it in building is we have to repair, we have to maintain it properly, we have to repair it properly, we have to rehabilitate it in time, and while doing so also we are supposed to rely on the material which are more we say sustainable type of material. For example, supplementary cementitious type of material for repairing rather than going for the polymers and all. Right, so you do the comparative analysis, and here we use metakaolin to replace the polymer latex in the repairing method. There was a repairing mortar which was used by the industry. So we cut down, the industry was using 7% of the polymer latex. We cut down that particular quantity to 0.5% of polymer latex. We added some 10% of metakaolin as the weight of the cement and use that whole mix on the repairing. We got this composition patented recently. So these are the case studies which we did for that particular project, where you can see here there is a column, de-stressed column, and in this column the last photograph, if you can see that the mortar or the plaster which is being used for this column restoration has 0.5% of polymer latex and 7% of metakaolin, and it gave the same good result as the earlier industrial mix was giving us. These are the results. So herein we achieved the process sustainability. Okay, so I will wind it up now. The conclusion, if someone asks me what is the definition of a sustainable construction material, then I will not take the name of any of the material which is appearing or to me as a sustainable material. But the material will be sustainable only when there is a material durability through the process of reuse. If you are using a low energy material in manufacturing one building unit, say brick, low energy raw material, but it does not have a recycling potential, it means it has lost its material durability or the sustainability at the end of the life cycle. So material durability through the process of reuse, you should be able to put that material at the end of the life into some reuse again, or you should be able to recycle it again. In that term, cement happens to be most non-sustainable construction material, in my opinion. You can make it sustainable only when you change its raw material completely, because you cannot recycle it at the end of. Now you can make it sustainable. You can call your cement as a sustainable if you are using fly ash as a replacement to cement while manufacturing it, or you are using the cement to make a very long durable type of component. Then second should be sustainability achieved through the process durability. Good quality control while manufacturing the products or units. Through the process of reducing. Reduce the consumption at the source itself. Keep the resources for future generation. That is what the sustainability is. Third is system durability. In system durability, as I explained you for that building model, it should be a holistic design. Means if the material is falling short in raw material sustainability, it should be good in the usage phase. Maintenance should be there, repair, retrofitting, rehabilitation should be there, and a life cycle, whole life cycle analysis should make your material as a sustainable material. This is all from my side. I hope I am able to convey a different approach towards sustainable construction material to you. Thank you. If there are any questions or otherwise, I'll wind up here.
Ma'am, can you just brief out the methods, like how to quantify this sustainability aspect?
Yes, if you are trying to use any material as a sustainable construction material, to justify it, make a systematic diagram for the life cycle of that material from extraction to the utilization. Associate the energy to it, to each step of it. Calculate the total energy required by that material and then compare it to the conventional material which you want to replace. Simple example, cement and fly ash. I want to compare, right? When I want to compare, what I'll do, I'll make the life cycle of the cement. So limestone extraction, then crushing, then the reaction in the rotary kiln, then the pulverization and the packaging, and then the supply, right? Fly ash. Extraction as a waste. So zero energy in production. Transportation. That is the only energy we require. Compare it like, and then when you compare like this, then you are able to see the difference between the energy and the emission required for each of the material. There you can justify.
Okay, thank you, ma'am.
Yes, thank you. So I'll leave the meeting now. Thank you once again for giving me the opportunity to talk to participants. I hope I am able to put a different approach.
Thank you, ma'am, for your valuable time spent with us to share knowledge on concrete durability and sustainable materials. We could understand more about sustainable materials and how energy can be conserved and how we can call a material sustainable. Thank you, ma'am, for sharing this much information with us.
Thank you so much. I'll leave the meeting now.